Hello, everyone. Welcome to today's webinar. I want to just let you know, please deal with me, okay? I'm dealing with a head cold, and if I sound a little stuffed up, I'm sorry about that. But I do want to introduce today's webinar. It's titled Space Heating with Electrical Radiant Heated Floors. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your day to attend this webinar sponsored by Schluter-Systems. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions. We will answer your questions at the end of this presentation. If the audio on your computer is poor, please use the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented, giving you easier access to watch and or share all current and past programs at your convenience. All right, I'm very excited. This is the first time this speaker has been done a program here with NTCA. Patrick Neaton. He's worked in the electric radiant floor heating industry for 17 years. He's currently a product manager for the heating and lighting cluster at Schluter-Systems. He is responsible for the overall management of the Heat and the Liprotech product portfolios. Heat is an electric radiant floor heat system, and Liprotech is illuminated profile technology primarily focused on wet applications. Patrick, welcome. I'm looking forward to your presentation.
Thanks, Jim. I appreciate the introduction, and thank you for letting me present today. I'm going to jump into the presentation here, and doing that, I'm going to stop sharing my webcam so I can see my screen better. But again, thank you, Jim, and I'll dive into it here. So, space heating with electric radiant heated floors. I'm just going to go through the presentation. There's about 36 slides. And again, I just want to have an open discussion and present the material that I have here, and we'll jump into it. So again, my name is Patrick Neaton. I am a product manager. Jim introduced me in the heating and lighting cluster, or what we call our business cluster at Schluter-Systems. So the learning objectives of this presentation. So after viewing this presentation, you should be able to describe the difference between radiant heat and convective heat. Describe the advantage of using in-floor heat in a tiled floor installation. List scenarios where electric in-floor heat can be used to reduce the reliance on other heat sources, and list the factors impacting a room's ability to regulate the temperature. So let's take a look at radiant heat versus convection heat. So what is radiant heat? The process by which energy leaves the surface of an object and travels to the surface of another cooler object in the form of electromagnetic waves. Characteristics of radiant heat energy. It travels from warm surfaces to cooler surfaces that absorb it. I think if you just an example, if you put an ice cube on a hot sidewalk, even though it's going to melt, again, you're transferring that warmer surface is melting the ice. So it travels from the warm surface to cooler surface that absorb it. It becomes heat when absorbed, and any surface can emit radiation to any other surface within sight of it. In the context of a heated room, let's look at the temperature distribution of forced air emitted from baseboard vents, and then you compare that of radiant floor heat. With convection heating, there's significant temperature variations throughout the room. You can tell the diagram on the left sort of shows that. With the radiant floor heat, there's an even distribution of temperatures, right? You're creating that thermal mass, you're heating from the floor up. Consistent temperature at the head level is achieved through radiant floor heating and results in ideal thermal comfort for the occupants of that room. Thermal comfort of the room occupants is achieved when the rate at which our bodies release heat equals the rate at which it's produced. So if your body releases heat at a rate that's too low, you're going to get uncomfortably hot. If your body releases heat at a rate that's too high, again, you're going to get uncomfortably cold. So radiant heat is ideal for the thermal comfort of the individuals within the room. Advantage of heated tile and stone floors. There are many advantages to consider when you're considering electric floor heat. It produces comfortable and consistent heat for the occupants in the room. It is energy efficient. It's environmental friendly. And there are some health benefits to that. We're going to take a look at each one of those more closely. Tile and stone are optimal materials for conducting heat because of their low thermal resistance. Heat passes through the tile very efficiently, radiating to the occupants above, providing them with a comfortable space. Because electric floor heat, and this is environmental friendly, because electric floor heat is capable of offsetting conventional means of heating, it reduces the reliance on fossil fuels, gas, or an oil furnace. This approach falls in lines with the direction we're heading regarding what type of energy we use as a society. For example, clean power that is generated by wind, solar, or hydroelectric sources. Radiate, there's also some health benefits. Radiant heated floors provide a health benefit versus convection type heating, as dust, germs, and allergens are not pushed around in the space. It also provides optimal humidity. Maintaining optimal humidity levels in the home is beneficial. Spaces that are too dry promote bacteria and viruses, and spaces that are too humid promote fungus and dust mites. There's other advantages of in-home radiant floor heat. A heat source installed beneath the finished floor, offering a silent and invisible solution. In-floor heat systems do not require ductwork, boilers, valves, or any other additional equipment. It provides comfort at lower air temperatures. And we go back to the slide that we showed before in terms of against baseboard heating versus a radiant floor heat system. You're heating from the ground up and providing that comfort. And reduces or eliminates air temperature stratification. So if you think about that, if you have a room with a really high ceiling, right, and you have forced air heat vents at the top of the room, it can be uncomfortably hot towards the top of the room, and then it still remain very cool at the bottom. So that temperature, that layer, that stratification, again, going back to the slide earlier, it reduces or eliminates that air temperature stratification. It also reduces the reliance on other heat sources. When a tiled floor is assembled, a thermal mass is created and stores the heat. This can be beneficial for limiting energy use during peak demand hours when electricity is more costly. With an electrically heated tiled floor, energy consumptions can be reduced during peak hours, which lead to money savings. Comfort is significantly reduced as the stored heat in the floor's thermal mass continues to radiate to the occupants. When peak consumption period ends, the heat is turned back on when energy costs are less expensive. And we're all familiar with this, and we've all probably received flyers in the mail from utility companies that are offering thermostats and wanting to, use energy on, non-peak hours. And again, an electric radiant floor, you're going to create that thermal mass. You're going to be able to do that and preheat it, and it's going to hold its heat, so you're not going to use less energy during peak hours. The next stage, we're going to talk about secondary stage heating. This is a combination of using, electric radiant floor heat along with a baseboard heater. So second stage heating is an approach that can be used to augment the existing heat sources such as the baseboard heaters. For example, they can be connected to the same thermostat. The connection to the thermostat is made via a relay, the connection of the baseboard to the thermostat. The task of bringing the ambient air temperature to the desired set point ultimately is going to fall to that baseboard heater, whereas the in-floor cable is limited to warming the tile exclusively. In this scenario, power to the in-floor cable will turn off once the desired set temperature is reached, while the baseboard does not shut off until the set ambient temperature in the room is reached. So again, it's also prioritizing the heating of the cable on the floor. You want the warmth on your feet. You want to heat, you want to feel that first. But again, if you don't want to run your floor temperature to 90 degrees and you want to keep it at a comfortable 80, then you can activate the baseboard, which again is going to bring the ambient air temperature to the desired temperature that you want. So the question is, can electric radiant floor heat be used to space heat? So in a remodel scenario where you're considering heat sources, electric radiant heat might be evaluated as a singular source. So the question is, can electric heat be used to heat to space heat? And the answer is, again, you have to do your homework. You know, again, at Schluter, our position is that we want you to consult with a heating expert. You know, there's 9 different climate regions within the US alone, right? So you want to have a local expert. Our expertise is in the tile industry. You know, consulting with a local expert on the heating requirement for your house is our position. Again, that's just the way we go at it. But again, the main point is no matter what you do, you have to do your homework. And you have to do your homework because there's a lot of factors that are going to impact the space heating, right? The R value of the space, the room. If installation is over slab on grade, if you're installing the tile over slab on grade, is it insulated, right? The quality and the quantity and the quality of the windows, the configuration of the room, the size, the height of the ceiling, all those factors are going to impact whether you can heat the space. There's subfloor characteristics, what we talked about. Also the climatic zone, the age of the dwelling. Those are all these factors could have a determining effect on an electric floor heat system's ability to perform at a satisfactory level. So that's why, you know, we suggest consulting with a local expert on the BTU requirements for your project. If through thorough consultation with an expert and the unique circumstances of the space discussed on the previous slide are favorable for space heating with an electric floor heating system, most of the systems in the industry produce between 42 to 45 BTUs per square feet. And if you look at all the manufacturers that provide electric radiant floor heat systems, they're all in that range. There are other factors of an in-floor heating system that can contribute to the positive outcome as well. For example, the underlayments available on the market that act as uncoupling membranes ensure lasting durability of the tile covering. They also serve to secure the heating cable in place. Some underlayments are capable of improving response times when heating is turned on. This enables achievement of the set point quicker and using less energy in the process. The membrane on the right features a thicker fleece laminated to its underside. This fleece acts as a thermal break, resulting in faster warm-up times when it's installed over concrete. Concrete absorbs heat energy, so incorporating a thermal break is going to prove beneficial at the power up. You know, if you look at the image on the left, 50% of the heat is lost to the concrete slab. If you look on the image on the right, 80% of the heat is directed upwards to the tile surface due to the thermal break. So again, there's a difference there, right? You're not going to completely prevent loss to the substrate, but again, it's acting as a break and it's going to improve your heat up time. This is an example with using our membranes. We have a Dietrich heat membrane, a Dietrich heat duo, and this just sort of speaks to the performance over concrete. And you know, you're not going to get much benefit. I'll talk about the slide next. Is, you know, and again, this is in our handbook, but over wood. But you're going to get that benefit over concrete. So, you know, obviously the tests are going to result in various, you know, they'll vary depending on various factors, the concrete thickness, the temperature, the room temperature. There's other factors that could influence this test as well. But if you look at both heating cables installed at 3-stud spacing, which is about 3.5 inches, that's the spacing of the wire installed in the membrane. You know, when you go from 68 to 78 degrees Fahrenheit, it takes about 115 minutes with Dietrich heat. And then if with a duo, it's going to only take 25 minutes. So it's going to reduce that. It's not going to prevent some loss to the substrate, but again, it's going to improve the response time. You know, which again, this represents a 90-minute or 80% time savings. And this is performance over wood. So the same scenario, you know, using Dietrich heat membrane as well as Dietrich heat duo. again, you're not going to get much benefit or much more benefit over wood. The real benefit is over on the previous slide when you're looking at sort of a concrete substrate. Again, the laboratory tests are going to vary depending upon the other factors in the room, such as the plywood temperature, the room temperature, etc. But both heating cables, again, are installed at 3-stud spacing or 3.5 inches apart. The wire is installed. And again, it takes about 25 minutes to go from 68 degrees Fahrenheit to 78 degrees Fahrenheit with Dietrich heat. With Duo, it takes 20 minutes. So, there's only a 20% time saving. You're right. You're really not getting the benefit of using a membrane with a thermal break. And again, we're talking about thermal breaks versus insulation or thermal barriers. So a thermal break is going to, reduce heat loss at startup, has a faster warm-up time, and improves efficiency, again at the startup. Thermal installation, it's going to reduce heat loss during the operation. It provides a higher R value, improves overall efficiency, but it may require added heat. Like you might, to get that insulation on, underneath the tile, you're going to probably add height to the assembly. So the R value might be, the R value of, the thermal break that, we have is 0.35, BTUs per foot squared. And that might appear to be low, but this is because we used it to thinking of R values for exterior walls and roofs, right? The thermal break is sufficient just to direct the heat up through the assembly. So it reduces the flow of thermal energy. And there's smart thermostats. There are smart homes that are enabled by such platforms as Google Assistant and Alexa. They're becoming basic household items. I'm sure a lot of you in the audience have such as, or use connected platforms. Consumers more than ever are maximizing control over the living spaces through integration of smart devices such as lighting, door locks, and even thermostats. To fill this customer demand, we've introduced what we call our Dietrich Heat ERS1 Smart Thermostat. It's designed to give full and convenient control to the homeowner. You control the thermostat in home using convenient voice commands such as smart home assistants, and controls the thermostat remotely using an app. And it also helps save on energy consumption as well. If you use a program schedule to minimize the energy consumption of your Dietrich Heat floor warming system. And there's also other features such as geofencing, which will automatically turn down the heat when you're away. So again, talked about it's controlled via an app, and you can connect, manage, and you can control your floor warming from basically anywhere. So that's the advantage of the app, and a lot of the thermostats in the industry all have connected apps. Again, this is an image of geofencing. You use a geofencing figure to trigger the preset programming on the T-stat based on the physical location of your mobile phone. So it acts off the cell signal on your mobile phone. Again, as long as your phone remain inside the radius, your thermostat's going to stay on. If you leave that defined area, the thermostat is going to turn off. So again, that's another function that a lot of thermostats have that are able to, reduce energy. It's an energy saving feature that it's included. So again, that says T-stat in away mode, automatically reducing energy consumption. So just some of the key takeaways that we want to talk about. The tile industry plays an active role in introducing floor heating solutions to consumers. In order to create positive outcomes for consumers, it is necessary that we guide them by managing their expectations properly. Electric radiant in-floor heat provides many advantages. It's efficient, it's evenly distributed, and it has some health benefits as well that we discuss. Electric radiant floor heat can also reduce the load on other heat sources. And like in his example, and I think this is sort of anecdotal, but if if you have gas furnace as the main source of heat in your house, right? And you wake up in the morning, if you have a warm tiled floor, you're not going to crank up the heat on your gas furnace, right? You're going to rely on that heat in the bathroom, and the comfort you want that's going to be at your feet. So, and again, you're reducing that reliance on, turning up the thermostat for other heat sources. In some cases, it may be possible to heat exclusively with the heating cable. But again, as we discussed, there's a lot of factors that go into that. You got the windows, the substrate material, the age of the dwelling, the existing installation. Again, it's the main point is it's critical that you do your homework and you consult with an expert if needed. And also there's other materials, as we discussed, that have thermal breaks. So again, went through pretty good. I'm sure we might have quite a few questions, but again, I'm going to open up for that if I can go back to any slides. I do appreciate the time, but then I also appreciated to have the discussion and present to you. So Jim, I think if we can, if there's any questions now, we can open it up for that.
Well, you know what, Patrick, you did a fantastic job. I don't have any questions that have come in. We had a great audience here, and I want to thank everyone for their time. I want to remind everyone, if you're at coverings, please come by the NTCA booth and say hi and let me know you're attending these programs. That's fantastic, Patrick. That was a lot of information in there. And I want everyone to know, if you think of a question, tomorrow you'll get an email from me thanking you for attending. You can just reply back what your question is, and then I'll make sure Patrick gets that, and he'll answer those questions. But I want to just say thank you to everyone. Our next webinar will be May 9th after coverings, and I hope you all there at that time. Again, Patrick, thank you. And everybody have a great weekend, great rest of the week, and we will all meet again on May 9th. So thank you all. Bye-bye.
Thanks for your time. Thanks, Jim. Thanks for letting me present.
Thanks, Patrick. Bye-bye.